Welcome to a very special EBS Storage Day session. In less than 2 weeks, on August 20th, EBS will celebrate its 15th year anniversary. Hi, I'm Mark Olson, a Senior Principal Engineer, and I've been at AWS focusing on storage and storage virtualization, and have had the pleasure of building features that improve the EBS product for almost 12 of those 15 years. Now, most of you watching this are at least vaguely familiar with Amazon Elastic Block Store, or EBS. But to ensure we're all on the same page, let me give you a brief introduction. EBS is a service that provides persistent storage that we refer to as EBS volumes for EC2 instances delivered over the network. EBS provides the ability to create snapshots for backup, data resilience, and data mobility. It's important to remember that an EBS volume is not just a disk with your name on it, but it's a large distributed system that's constantly monitored and operated by our engineers. Now, this ensures that we meet the goals for availability, durability, and performance, all while providing a large set of volume types and data services to meet your needs. The core foundation of EBS, that's storage and snapshots, was laid over 15 years ago. At launch, EBS volumes could be created empty from a snapshot. And of course, you could create new snapshots as your data changed. EBS is a service, and that allows us to continue to iterate on your behalf. Let's go through a few of the features that we've built over the years in response to your feedback that make EBS what it is today. In the early days, EC2 instances launched with a large object that you created and had to manage, separate from your EBS snapshots. And the first EBS volumes were only available as persistent data volumes. We created the concept of EBS-backed AMIs, based on snapshots that allow you to boot from EBS. Now, we take all this for granted today, because most launches today are EBS-backed. But EBS-backed boot volumes allow you to stop your instance and restart it later. It also enables EC2 auto recovery to automatically move and restart your instance when the underlying hardware has an unexpected failure. EBS started with the most widely available storage media in 2008, hard drives, or as I like to call them, spinning rust. Hard drives are great at storing data, but less great at predictability, especially when it comes to small I/O transactions, something that became more and more common as you started migrating databases and other similar workloads to EC2 and EBS. Now, if you've ever taken apart a hard drive, there's a ton of engineering that goes into building a hard drive. You've got platters spinning at 150 miles an hour, a big giant arm that swings back and forth, trying to find that right spot on the platter to read your data. Now, if you picture this, small random I/Os create a ton of problems because you have to land that arm and swing it back and forth across the tracks. So predictable performance became one of our most requested features. In 2012, we launched provisioned IOPS, our first volume type based on SSDs, and our first volume type that allowed you to provision your performance requirements with a more predictable and consistent experience. At the same time, we launched EBS optimized instances. EBS optimized instances dedicate network throughput for your EBS volumes. Now, originally when we built this, it was an opt-in feature. We recognized that just about every customer was choosing it, so from 2015, we made it the default for most instance families. We took it one step further with Nitro. We provide your instances burst capability for smaller instance types. And what this allows you to do is get higher peak EBS performance without having to overspend and overscale your instance. Customers love the more consistent experience and performance of IO1 volumes. But we got feedback that for many workloads, there were just too many knobs to worry about. So we set out to design a volume type that just works for most workloads. And in 2014, we launched GP2 volumes. Our goal with GP2 was to create a predictable volume that didn't require you to know the specifics of your workload ahead of time. It would just scale with your needs. GP2 volumes offer low single-digit millisecond, or SSD-like performance, at a low cost. Security is also important, and we knew that a lot of our customers were encrypting their data inside of their instances. We asked ourselves, why can't we do it for you? And with the launch of encrypted volumes in 2015, we take care of encryption and key management, transparently. In Nitro instances, we took it one step further by encrypting the data in dedicated hardware. Now, this improves encrypted volume performance, and it provides even stronger protection for your data and the key material protecting your data. Further innovations include predictable and lower cost hard drive volume types with SC1 and ST1 which are both designed for throughput workloads. And they have similar operating characteristics. The main difference between these two is the level of performance that you get and the cost associated with that. With more volume types and more knobs, customers asked us to make it easier for them to either trial and test different workloads or help them save cost and scale to meet their demands. Elastic Volumes does just that. It gives you the ability to move your volume type, increase storage space, or increase or decrease performance, all while your application is running with no downtime. Now, I've had to pick just a few things to focus on because I don't really have a whole lot of time. But up until this point, I've been focused mostly on the core EBS volumes. I'd be remiss if I didn't talk about snapshots and one of my favorite features, Data Lifecycle Manager. DLM allows you to control the lifecycle of your snapshots. Our customers use DLM policies to create lifecycle and retention policies, leaving the scheduling and processing up to EBS. Now, with the right policies in place, you can rest knowing that your data is safe without runaway costs. EBS volumes, when created from a snapshot, hydrate that snapshot data out of S3. With Fast Snapshot Restore, it removes the impact of hydration. When Fast Snapshot Restore is enabled for a volume, you get your volume's full performance without having to wait for the data to populate. Great for those disaster recovery scenarios. EBS Direct APIs allow you to create and access your snapshots without creating an EBS volume. We see customers using this for a lot of use cases, but some of the most common are on-premises backups, data migration, and security scanning workloads. You've asked for clustering solutions, and our high-performance provisioned IOPS volumes are able to attach multiple instances at the same time. Now, if you're going to use a multi-attach volume, I have some cautions. You must use either an application or a file system that is cluster-aware, or you're going to get surprising results. At EBS, we haven't spent all of our time focused on features and volume types, but we've also been looking at improving our infrastructure. Now, since we operate as a service and not just a generic storage array, we're able to deliver those improvements behind the scenes so that you get the advantages with little to no work. Sometimes these enhancements do form the basis of new features and volume types as well. And you can see that with the second generation of provisioned IOPS, or IO2 volumes. EBS now has a volume with 5 nines of durability and even lower latency than IO1 volumes. Hot on the heels of IO2, we launched a new general purpose volume. GP2 was designed to scale performance with the size of the volume. And while this works for many customers, your workloads are changing. Some require higher performance. Some require the ability to scale down that performance when you don't need it. GP3 is designed for those customers that may need or want the ability to scale performance separate from storage, maybe to handle peak periods, and then you can return back to a baseline. GP3 separately supports both IOPS and throughput scaling, so you can adjust the volume performance to match your workload. Even with this flexibility, as a general purpose volume, GP3 still comes with an easy mode. It has some baseline performance that works for most applications. Our infrastructure changes also allow us to deliver even higher performance for provisioned IOPS volumes. You can see this with the launch of IO2 Block Express volumes, where you can now provision up to 256,000 IOPS and 4 times more storage, up to 64 terabytes per volume, all at sub-millisecond latencies. We'll talk about one of the key changes in a moment. We've also launched features that enable you to reduce costs, like Snapshot Archive, a cold storage tier for storing snapshots long-term, satisfying many security and compliance requirements. Sometimes, we can accidentally get a little overzealous with deletes. Recycle Bin allows you to create a policy that stores those snapshots temporarily in the recycle bin, allowing you to recover them if you need to. And you can also ensure that those policies cannot be changed with rule lock, helping you protect against potentially malicious actors. AWS Fault Injection Simulator allows customers to run experiments on their applications, simulating failures of different parts of their AWS infrastructure. EBS integration allows you to simulate a network failure that may prevent timely access to your EBS volume, and test how your application responds and your failover runbooks and mechanisms. While this is just a snapshot, pun slightly intended, of features that we've delivered, these and all the others that I haven't mentioned bring us to the EBS of today, a service where our customers create 390 million EBS volumes per day and support your workloads that drive more than 100 trillion IOPS daily. As a data plane engineer, I could talk all day about our architecture and performance enhancements, but let me focus on one really cool innovation that I'm proud of. Several teams within AWS collaborated, and we asked ourselves, how can we take better advantage of our network architecture? And what we came up with is what we call SRD. SRD is a foundational network protocol designed for our data centers to deliver lower latency, higher throughput, and fast repair around failures in the network, leading to much lower outlier latencies. Instead of relying on traditional networking, routing, and convergence protocols, which often take seconds for the network to learn new paths and route around failure, SRD is constantly probing multiple paths through the network. It's able to react to congestion and failure events within hundreds of microseconds. The load balancing also leads to higher throughput between two endpoints. And at AWS, we use SRD for EFA, ENA, and many EBS volumes. When applied to EBS, we see a 90% decrease in tail latencies, allowing your application to be more responsive. The improvements in network and software efficiency, when compared to more traditional network protocols, also help us deliver 4 times the throughput to EBS volumes. Now, this is especially important for our customers with low latency, high transaction rate databases. One example is KDB+, a time series database designed for high-speed processing of large data sets, and it's common in financial services. The Security Technologies Analysis Center, or STAC, has developed a set of benchmarks tools for common financial applications, allowing these customers to have a method to compare different workloads across different platforms. We're seeing a growing number of customers wanting to ingest and analyze market data, so we specifically chose STAC M3 benchmark, which represents this workload for this example. In our test configuration, we used EC2 X2 IEDN instances, which is a high memory instance, along with IO2 block express volumes. IO2 block express volumes leverage SRD. And then we put the KDB plus data store on top. The test results showed that the high performance offered in this configuration is particularly suited to workloads that require a shared data set presented to KDB plus clients in a distributed configuration. Another growing storage use case is AL model training and inference. With the high throughput and multi-attach capabilities available with IO2 block express, customers can share data sets across multiple instances while maintaining high performance without incurring the additional cost of a locally attached SSD. Reducing tail latency is important for these workloads. You want to fully utilize the inference, training, or general purpose GPUs. Any moment spent waiting for an I/O is an increase in the amount of time your workloads take, and it also increases your cost. Shared EBS volumes also remove the time it takes to fetch your dataset and load it into memory, or a local storage device. Elastic Volumes is a feature that allows you to make changes to your volume while it's in use. You can change type, size, and performance characteristics. Consider a dataset that's relatively new and not getting a ton of use. Or maybe you yet don't know how it's going to be used. Since you know that GP3 is going to be a good all-purpose volume, you start there. As the load ramps up, maybe you need the lower latency that IO2 provides, or the higher scale. After the initial spike, the load drops off, and you're able to move back to a lower performance volume, saving cost along the way. Perhaps you're able to land on an ST1 volume for some period of time. After some point, you start to see sustained growth, and so you're able to transition it back to GP3, and as you grow further, IO2, all with just a few simple API calls. One of the things that I really love about working at AWS and EBS is the ability to talk to customers and understand their use cases. Devo is a cloud-native analytics customer that's using Elastic Volumes to meet their needs. Using a high combination of current generation instance types, with EBS GP3 and ST1 volumes, they're able to meet the expectations of their customers for optimized compute, memory, and storage. Now in 2021, Devo initially migrated their GP2 volumes to GP3 for data replication. And with this, they were able to realize a 20% cost savings while maintaining performance. Since then, they further adjusted their workflows by moving to ST1 volumes as the data becomes less accessed and perhaps during non-peak hours. For Devo, ST1 volumes allow them to drive the throughput they need at a lower cost. Now, they also leverage CloudWatch to monitor the performance credits that are available on their ST1 volumes. And what they're able to do is migrate back to GP3 as the demands on their performance increase using elastic volumes. With this strategy, Devo can quickly scale its solution capacity, tune performance, and change the type of live volumes with zero interruption to their workload. By scaling IOPS and throughput with additional block storage, Devo pays only for the performance and storage that it needs. More and more customers are taking advantage of EBS for their mission-critical workloads, and there's no better example than SAP. SAP applications are often demanding analytics workloads for industries like manufacturing and retail. And we have many customers that have either done a lift and shift migration of their existing cluster or a transformation to SAP HANA, the cloud-native platform. With EBS general purpose and provisioned IOPS volumes, all certified to work with SAP, this allows you to build the solution you need at the right cost and performance. For mission-critical production workloads, we strongly recommend IO2 or IO2 block express volumes. Now, EBS does allow you to mix and match volume types attached to your instance. For example, you can use ST1 volumes to back up or store your SAP HANA backups, further optimizing your cost. Every Nissan car is made up of thousands of components and is built on a complex construction line, which means there's a lot of data to analyze behind the scenes. Nissan in Europe's on-premises data center strategy needed to change to meet their increasing demands. The performance of EBS allowed them to migrate their application into AWS, while the scale and flexibility of AWS allowed them to reduce and compress their database, reducing their hardware requirements, saving cost along the way, not just at the next hardware refresh. In addition to seeing a runtime performance improvement, Nissan in Europe uses EBS snapshots to reduce the amount of time needed to recover from a failure. With snapshots, they don't have to reload all the data, just the data that's changed since the last recovery point. The neat thing about operating in the cloud is that if they need to scale up the cluster temporarily to support a new initiative, they're able to acquire the additional capacity, whether it's compute or higher performance EBS volumes, whenever they need to. As with any type of storage, we encourage our customers to have a robust, secure backup strategy in place to secure data. Snapshots are point-in-time copies of your data that are stored in S3, and they give you immediate access to EBS volume data, the ability to resize EBS volumes when you create them. Now you can also use EBS snapshots to share data and copy snapshots across regions, providing you geographic protection of your data. I mentioned Snapshots Archive briefly. If you have a need for long-term retention of snapshots and a longer recovery time is acceptable, you can lower your costs by leveraging our Snapshots Archive tier. These can be used for things like quarterly compliance copies, or maybe you're winding down a project but you need to keep the data results on hand. You can even use Data Lifecycle Manager to automate moving snapshots to the archival tier. Johnson & Johnson, one of the leading healthcare companies, has a comprehensive backup strategy for compliance, disaster readiness, and business continuity, and snapshots play a large role in their strategy. Johnson & Johnson has strict compliance requirements, often requiring data to be kept for 20 years. As their business grows, so does their data, and cost optimization is important to their business. With EBS Snapshots Archive, Johnson & Johnson was able to migrate over 100,000 snapshots in less than 2 months without any disruption to their business processes. Now, this migration resulted in a projected cost savings of over $1 million annually. I hope you've enjoyed today's trip through memory lane as much as I have. Happy birthday, EBS, and I look forward to the next set of features we can build for you, our customers.